Concentration in stoichiometry. A 0.1 liter sample of an unknown nitric acid solution required 34.9 milliliters of 0.2 molar barium hydroxide for complete neutralization, acid-base reaction. What is the concentration of nitric acid solution? So we have 0.100 liters of nitric acid, and we want here the molarity. We don't know the molarity. We're also given 34.9 milliliters of barium hydroxide and 0.200 molar. So to many people, many students, it looks like, all right, 2 volumes, 1 molarity, I want another molarity, I'm going to use dilution equation. M1V1 equals M2V2. However, you cannot use that here. This is a neutralization reaction. There's stoichiometric things happening with the mole ratio, and you have to take that into account. So it's really similar to doing all of the other grams to molar conversions with very similar to limiting reactant theoretical yield that you've done already by just converting to what you want, starting with what you're given. So nitric acid is going to be towards the end of the problem. We're given information for barium hydroxide. Another way I always like to write the molarities, I like to say, well, 0.2 molar means 0.200 mole over liter. And I know that 34.9 milliliters, if I divide that by 1,000, gives me 0.0349 liters. Well, if I use these two, I can get moles. Because I want information of nitric acid and I want molarity. If I want molarity, I need mole over liter. I have the liter. This is what I need to solve for. Well, if I'm going from one compound to another, I must use mole ratio. And I can see that from my barium hydroxide information, I have enough to get exactly the moles. So I start with 0.0349 liters and multiply that to the concentration, 0.200 mole per liter. This cancels out the liters. This is for barium hydroxide. Now I can use my mole ratio. My mole ratio is 2 to 1. So 2 moles of nitric acid, because that's what I want, over 1 mole barium hydroxide. This then cancels out my moles of barium hydroxide, and I'm left with moles of nitric acid. So 0.0349 times 0.2, divide and multiply that by 2, gives you 0.01396 moles of nitric acid. Now we want molarity. Now that we've got the moles and we have the volume, molarity is then equal to moles over liter. So then that'll be 0.01396 moles divided by 0.1 liter. The units don't cancel because you don't want them to, since it's already in moles per liter. Divide by 0.1, and you get that the concentration is, we want 3 sig figs, so 0.139 m of HNO3. So the difference between this and dilution problems is the fact that here you have a reaction. And when you have a reaction, you have to convert from one substance to another. When you are converting from one to another, you must use mole ratio. So if we were given atoms, grams, etc., we always first go to moles. Here we were giving something new. We were given concentration and volume. Using those two, we were able to find moles. Then use that to get the mole ratio and solve for the moles of what we wanted. Now, if we wanted moles, we would have been finished. If you wanted atoms, you would have used Avogadro's numbers, grams, molar mass. But here we had to use the volume to get concentration. So there you get the answer that you want. Very similar to